See, you put one in the debate and then you do the second one. Yeah, that's what you
Megan,
did one.
Wednesday, maybe?
No, word is that you got absolutely destroyed by the game.
I did, you're right.
All right, let's take a look on page 212. We're going to continue with our implicit derivatives, x's and y's mixed in. And then we're going to do kind of an intro to our next section that we're going to start tomorrow. On page 212, I think we left off yesterday talking about the second derivatives for these implicits. Is that right? Yeah. Did we finish the first one? Yeah. Okay. Let's go ahead and try the second one. So notice how the x's and y's are mixed in. In order to find the derivative, we're going to have to write dy over dx every time we take the derivative of a y variable. But in this case, they want us to do another derivative. Okay, the second derivative, we'll see how that works out. All right, derivative of x squared, 2x, plus derivative of y squared, 2y, dy over dx, equals derivative of 1, 0. Good. All right, so let's get the dy over dx derivative symbol all by itself. Should be pretty simple because there's only one of them. Good. Okay, so we'll subtract the 2x and then divide the 2y. Simplifies to negative x over y. All right, there's our first derivative. But they want us to go a step further, okay, go another round. So you got to ask yourself, how are you going to find the derivative of negative x over y? Quotient rule. All right, so we'll label this as the second derivative. So quotient rule, we need low d high minus high d low, derivative of y. What can we write? dy over dx. Good. Okay. Low d high minus high d low. Square the bottom, and we're good to go. So this is a good derivative. Okay, we found the second derivative in this case, but we're going to try to clean it up just like we normally do for any other derivative. Y times negative 1 is negative y, and if we subtract a negative x, that can change to a positive x. What can we do with this dy over dx? Substitute it. We already know what that is. Okay, this is just representing the first derivative. So we'll replace that with negative x over y. Now all of this is still over y squared. So we cleaned it up a little bit, but I don't know about you, it's still hurting my eyes. So let's keep going. We'll see where this can take us. We'll have negative y. And if we actually multiply these two terms together, we'll have negative x squared over y. And that's still all over y squared. Can we keep going? There's a lot of fractions in there. We should be able to keep simplifying. What do you want to do? Go, Christian.
Common denominator on the top, so you can make them one thing.
Okay.
And then the bottom multiplied by 1 over y squared.
Do the reciprocal, right? Okay, so common denominator, we'd have to multiply y over 1 by y on top and bottom, so it matches this denominator. So we'll have y squared minus x squared all over the common denominator of y. And Christian said instead of dividing by y squared, let's bring it up and multiply by the reciprocal. So it looks like our final simplified second derivative is y squared minus x squared all over y cubed. I think I missed a negative though. Did we see that?
Yeah.
Negative here, negative there,
Which means final answer.
negative there, negative there. Is that better?
No.
Alright. Those deg negatives. Alright, looks good. So in terms of these implicit derivatives, finding a second derivative isn't anything too complicated. The only really difference is we can do that substitution because we know we're eventually going to get that dy over dx symbol. We can replace it with whatever the first derivative was. Okay, so we have that to use to our advantage. What we're going to spend most of today doing is taking a look at this free response example from 2008. I know it's a little old, but it's definitely a good review of this particular section. Okay, so take a look at what we have here. This is, by the way, a non-calculator question. So we should be able to do all of this without utilizing our calculator. So consider the closed curve. We have no idea what this looks like. It might be a circle, probably not, but it's some closed figure. For part A, we need to show that this is what the derivative is. So they're actually telling you this is what the final answer should be. They want you to prove that that's true. Okay, show your work, do the steps. If it's a show type of question, make sure you show every step. Okay, I know some of you might be able to do them in your head. You might be able to jump to certain conclusions, but make sure you show every single step that there actually should be. So let's see if we can actually do this. Take a look at the equation. There's x's and y's mixed in, so this is definitely an implicit derivative example. Can we work our way through with the derivatives? Derivative of x squared, 2x, plus the derivative of 2x, 2, plus the derivative of y to the fourth.
4y,
Yep.
the one thing, and then cube it. dy dx.
dy over dx. Okay, so the regular derivative would be 4y cubed, and then since we took the derivative of a y variable, we need that dy over dx after we do the derivative. Then we're going to add the derivative of 4y. 4 dy over dx. And what does that equal? No.
Oh, 0.
0, 0, 0. I know it's going to happen, and it does every year. Okay, you got to do the derivative all the way through. Do you guys think you can go from there to get dy over dx all by itself?
Yeah.
Show that you get this. So it looks like when I solve for the derivative, this is what I get, but that does not match what it needs to be based off of what they want us to have. So did I do something wrong? No, I need to keep going. Okay, so my math is good, my calculus is good, we just got to keep going. Okay, make it look like this. So what else can I do? Factor out. What'd you say? A 2? Can I make it negative?
Yeah.
So this would be x plus 1. And then on the bottom, take out a 4, y cubed plus 1. So 2 divided by 4 can change to 1 over 2. Looks good. All right. Now, since this was an actual AP question, I know where the points are earned for all of these different parts. So if you found the original derivative correctly, that would earn you a point. And if you showed all of the work necessary to get the end result to be exactly the same as what they wanted, that would be another point. Okay? How do you think you would have fared on that part? 100%. Perfect. Okay? Now, each free response question is worth 9 points, so there are a few more points here to be earned. That's where we're going to go through B, C, and D. All right? Let's go ahead and try part B. Write the equation of a tangent line. What do we need to know? Point and a slope. Okay. Do we know the point?
Yep.
What is it?
-2, 1.
-2, 1. Okay, they give it to you in the actual question. How can we figure out the slope? What do you think, Megan?
You put like -2 in for x and 1 in for y
Into the derivative. Okay, so if this is the final derivative, okay, they're actually telling you that's the actual derivative in part A. So if this is the slope of the tangent line at any point, notice how you'd have to plug in an x and a y in order to get that slope value. So they're giving you both of those to help you out. Let's plug in -2 for the x and 1 for the y. So we'll have 1 for the top, and then one cubed plus 1 times 2, 4. Okay? So we have our point, we have our slope. We'll go ahead and write our equation. We need y minus y1. So from the point, that would be 1. Equals the slope times x minus x1. So that would change to a plus 2. All right, so on the actual AP exam, you would have gotten a point for the correct slope. So if you found 1/4, you got a point. And if you put all the information together to write the equation of a tangent line, that would be worth another point. How do you think you did? Good? Okay, so far. So 4 out of 9, not too bad. We're almost halfway there. Let's go ahead and check out C. Find the coordinates, okay, x comma y. Find the coordinates of the 2 points on this curve where the line tangent to the curve is vertical. So we have a vertical tangent line. Can we talk through it? What should we kind of analyze or try to find? What do you think, Anush?
The slope of the vertical tangent line would be something over 0.
Okay, so dy over dx, your derivative or slope, is undefined. So if a fraction is undefined, something over 0, right? So we would need the bottom of our derivative. We will go ahead and write that down. We need that equal to 0. Where do you want to go from there? Solve for y. Okay, so if we divide the 2 over, still going to be 0. Subtract the 1, we get -1, and cube root both sides. Cube root of -1, -1. I like it so far. Let's read the question again. Find the coordinates of the 2 points on the curve that have a vertical tangent.
Do we plug in a y into the original equation?
So at this, very good, at this y value, you know you have a vertical tangent, okay, based off of our derivative analysis. So if they want the 2 points on the curve, okay, that's the original one, let's figure out the x coordinate, because if we know a y, we can figure out an x. So we'll take x squared plus 2x, and then for every y, we'll plug in a -1. So x squared plus 2x plus 1 minus 4 equals 5. Where do you want to go from there? Quadratic, okay, so we'll get it equal to 0. -3, subtract the 5 over, we get -8. There's our quadratic. How do you want to solve for x? Factor, 2 numbers that multiply to -8, add to 2. 4, -2, so our x solutions, -4 and 2. Okay, read the question. Find the coordinates of the 2 points. So what are our coordinates? 2, -1. Okay, x, comma, y. And then the other point? -4, -1. Perfect. All right, on the AP exam, if you were able to get the y value of -1, that was worth a point. And if you were able to get both of the final points, that was worth a point. Okay, I don't really think they give half credit on the AP exam. So for this case, if you had one but not the other, you would actually lose the whole point. So it's kind of an all or nothing type deal. How do you think you would have fared on that one? A little tricky. Yeah. I'm thinking we would definitely be able to get this one. It's the other part where you had to like use that. Might be a little difficult, but still, if it's out of 9, I'm going to tell you right now, the national averages on these free response type questions are 4 at best. At best. I know. So if you can get, I know in your head you're thinking 4 out of 9, 5 out of 9, that's horrible. Okay? That's actually fantastic. So if you can get half of these free response questions correct, you're on a good track. Okay? You'd be surprised. Some of these free response type questions, national averages are 1. I've seen a 0.8 before. There are some tricky ones. Okay? So aim for, well, obviously aim for all of them, but don't be upset if you get half. That's still a really good score. All right? So if you're at 100% so far, you have 2, 4, you have 6. That's really good. Okay? So that means we have 3 points left to earn. Let's go ahead and check out D. Let's read the question. Is it possible for this curve to have a horizontal tangent at the points where it intersects the x-axis? Explain your reasoning. Can we develop a game plan?
It says it's impossible, so do you actually have to find the points?
Is it possible? Okay, so the question, is it possible, we're either going to have a yes or no answer, and then we're going to have to explain why is it a yes, why is it a no. Okay? So you have a 50-50 chance, you're right, but let's go ahead and, well, let's test it. Okay, is it possible? Can we, let's decipher this. Horizontal tangent, the derivative is 0, so the top of our derivative is 0. Okay, so we'll have negative x plus 1 equals 0. Can we solve for x?
Yeah.
X equals -1. Okay, so at this x location, you know you have a horizontal tangent. The question is, at this x location, do you also intersect the x-axis? How can we check that? Plug into the original and see if it's 0. Is that what you're going to say too?
I was gonna say raise your hand.
Wow.
Is that where you were going with though, Christian? Okay. So kind of similar to the last one. Let's plug in -1 for all the x's. So we'll get 1 minus 2. So let's see, if we set it equal to 0 like the previous one, y to the 4th plus 4y minus 6 equals 0. Can we factor that? Like the last one? It kind of looks like it, right? The only difference is this was a power of 2, that's a power of 4. Doesn't really work the same way. If you intersect the x-axis, what do you think, Anush? The y should be 0. If you're on the x-axis, you have a y value of 0. So if you were to plug in 0 for all of these y's, what do you end up with? -6 equals 0. Is that a true statement? Not at all. Okay, so is it possible? Does this horizontal tangent actually happen at an x-intercept?
It does not.
No, because it said explain your reasoning. No, because, well, I'm running out of room. No, because you guys should have more room on your paper than I have on mine. We're gonna do this. All right. No, because the only horizontal tangent is at x equals -1. But the point -1, comma 0, okay, x value, y value, is not on the curve. Okay, you don't have that as an x-intercept. So we're basically taking the mathematical work we did and just rewriting it with words. Okay, so this is the only horizontal tangent, but notice how the x-intercept does not happen at that spot. So if we had 3 more points to be earned for this part, you would have gotten 1 point for actually just finding -1 for the x. You would have earned another point for testing to see if it was an x-intercept or not, and you would have gotten another point for your explanation or your justification. Okay, no, because something. How do you think you would have fared on that one? I know we went through it together, but if you had to do it by yourself.
I would say there's probably about a 50% chance I would have done it right. But if I would have done it right, I would have gotten it.
Knowing what we did in C, I feel like I would have gotten 100%.
You-
I wouldn't have known to do that.
Known to do that, yeah. And that's what this, it's going to get tricky, because we're going to do a lot of them together, but I'm eventually going to make you do them on your own. That way we can get some confidence. Okay? How are we doing with implicit? Pretty good? dy over dx, we can remember to do that? All right. We're going to switch gears a little bit, and then we're going to take a look at an example of a word problem that we're going to be investigating in our next section.